Welcome to study for GATE and ESC solution. So we are starting with the 2 mark questions. Sorry for the inconvenience. Due to some reason I am unable to be upload all the videos, but shortly I will finish all the videos within this September to October. So don't worry that one. So we are studying for the network theorem. This is a 2 mark question. We are starting here. This is asked in GATE 97. This is a 2 mark question. So this is a figure they have given in question number 1. This is the figure they have given, and they are asking find this the Norton equivalence terminal A and B, and this is the one voltage source is given, this is one current source, and this is connected with in parallel. So they are asking terminal across this, terminal across A and B. They are telling find out the Norton equivalence across this terminal. So let's see its solution. This the circuit they have given. So if you solve this one is the closed loop. So if you solve this circuit, this is a 6 volt and the voltage across will be 3 volt, voltage across also 3 volt. So if you see this term only, its equivalent will be get 3 volt series 3 volt, and equivalent of 3 into 3, this is 1.5. so equivalent of this one will be this part, and the next part, 2 ohm ampere parallel with 3 ohm resistance. So if you transfer into source transformation, it will 2 into 3 into 6. So this is a 6 volt and a series with this 3 ohm. So transformation this figure simplify will be, we are getting this figure. So we have to calculate the Norton equivalence, means we have to be short circuit this one. So see in this figure, 3 volt plus 6 volt is equal to 9 volt. 9 volt, and the resistance 1.5 plus this 3 is equal to 4.5. So the short circuit IN current is equal to 9 by 4.5 is equal to 2 ampere. If you see this is the figure, so the equivalent R value is equal to, we short circuit these two one. So voltage source short circuit, so the R equivalent is equal to 1.5 plus 3. So the Rn is equal to 3 plus 1.5 is equal to 4.5. So the given the IN, the Norton equivalent is equal to ampere, the current is equal to 2 ampere, and Rn is equal to 4.5 ohm. Come for the question number 2. In this figure they have given that A and B to terminal, and this voltage resistance which is connected parallel with this voltage and resistance, and they are telling they find out this series a voltage source and series with a resistance, means they are asking find out this VTS and RTS. They are telling across terminal A and B. So in this figure they are indirectly telling find out this Thevenin's voltage and a Thevenin's current. This is the figure they have given in question number 2. So the given figure, this is the question they have given, and they are telling find out this Thevenin's voltage across A and B. So I am using here voltage analysis. So in this point, suppose this is A, this is B, this is equal to grounded. So I can be apply here Thevenin's voltage at the node A. So if you use here nodal analysis, we are getting this is VTS minus this 10 volt by 6 plus VTS minus 5 volt by 4 is equal to 0. So simplify this one, 2V minus 20 plus 3V minus 15 is equal to 0. 5V is equal to 35. So V is equal to 7 volt. So V we are getting across here. So VTH we are getting 7 volt. So the terminal A and B, we are getting the Thevenin's voltage will be 5 volt. So and next we have to calculate it's the equivalent resistance. So when we are going to be calculate equivalent resistance, this is short circuited, voltage sources are short circuited, and so we are getting 6 parallel to 4. So we are getting here 6 into 4 by 10, so 24 by 4. So the is equal to 2.4 ohm. So finally we are getting the equivalent Thevenin's 7 volt which is in series with 2.4 ohm. This is terminal A and B. This is the equivalent of the given question. This is the 4 option they have given. So we have got 7 volt in series with 2.4 ohm. So option B is the correct answer in question number 2. Come for the question number 3. This is the question number 3, and they are asking find out the voltage between this point P and Q, and this is the circuit they have given, and here is given one voltage source, one current source, and 4 resistance is given, and they are asking find out this different potential difference between P and Q. So we can apply here. This is the one node, this is another node, this node considered as a grounded. So we can apply here nodal analysis. So see its solution for this question. See in this figure, this is the figure they have given. Let's consider this point will be the VP, this node, this, and its potential will be VP, and you consider all the current are going away from this point. So apply nodal analysis here, VP, and see this figure. This is the plus or minus 10 volt means this also 10 volt. So if you apply here nodal analysis, VP minus 10 by 2 plus VP, this is 8 plus this current is already going on here, so is equal to 0. So this is, if you simplify this one, 4 VP minus 40 plus VP plus 16 is equal to 0. 5 VP is equal to 24. VP is equal to 24 by 5, which is equal to 4.5. So the potential across P point is equal to 4.8 volt. So similarly apply the nodal analysis at point Q. So we are applying, similarly applying here this. In this point also all the current are going away, but this is the current is incoming here, so this is the current is incoming here. So this the two terminals outgoing. So VQ by this 8 plus VQ minus 10 by 4 ohm is equal to 2, because these two are outgoing, this is incoming. So simplify this equation, we are getting 2 VQ plus 3 VQ minus 30 is equal to, after simplify 2 into 12, so 5 VQ is equal to 54. So VQ we are getting 54 by 5 is equal to 10.8. But in the question they are telling find out the difference between VP and VQ. So VP minus VQ is equal to 4.8 minus 10.8 is equal to minus 6 volt. So the potential difference between terminal P and Q is equal to minus 6 voltage, means the node Q is higher voltage than node P.